Live from the Icebox Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show. I'm Bill.
And I'm Corey.
Nice to hear you. Most of our questions today are on pressure regulators, but the first one is not on pressure regulators. Here's the question. We're having trouble with our nitrogen dewars freezing up when we're using the gas output. Would the 6284 series gas warmer solve this problem? What size inlet connection would I need for a nitrogen dewar?
This is our 6284 heater, which it's the only heater we carry. It's for making sure your pipes don't freeze and your gas is warm enough not to freeze your pipes. I spoke to the customer, and when he said his dewars were freezing, it really was the pipes as they were coming out of the dewar. And unfortunately for him, the flow rate wasn't high enough, but this one is 160 standard cubic feet per hour flow rate. It gets a heater temperature of 160 to 185. And it comes with the CGA connection already on it. So for this one, you'd order the 6284-580. And on a dewar, the gas output is a CGA 580, and the liquid output is a CGA 295. So you'd buy the 580 version, and you just connect right to it, and then it has a outlet of a CGA outlet, and then you can put your regulator right on the end of this, and it'll help keep things from freezing up.
Yeah, it's made to go between the cylinder dewar and your pressure regulator or flex hose. So it's got a CGA on the inlet and it's got a CGA bushing on the outlet. Okay, next question. Oh, we can't show the photo, but see the attached photo.
I'll
Can
show
you tell me what the threaded hole is for? It is not the inlet, outlet, or gauge port. Is it an overpressure relief?
So we're talking about this hole right here. And that is the Bonnet vent hole. And so for regulators, this is a different regulator. But so for regulators, this is a demonstration one. Inside there's a diaphragm. Here's the diaphragm right here. And so the spring will push down on it, and it'll push, and you hear the snapping, it'll push on this diaphragm right here.
And that pushes on the valve stem.
On the valve stem right there, if you can see it.
Yeah.
And so sometimes gas will leak through that. And if you're using a corrosive gas or even a flammable gas that you don't want to build up in a closed room, you need to vent that to a safe location. And that's what you'll do. You'll take piping, tubing, and just vent it to a safe location where the corrosive or flammable gas can go.
And you want to show them what else is in the bonnet, the top part of it?
Oh, the spring?
Yeah. See that there.
And here in the top part is the spring. And so this is what pushes the diaphragm down. As you twist it, it pushes it down. So, and that's how you can control your pressure.
Now, when you say sometimes leak, it's not really, it can leak.
It can leak.
Like a common
I'm
problem.
sorry, yeah. I mean, it's common enough that they put a Bonnet vent hole in it, right?
Well, no, I mean, you put the bonnet vent hole in there because
It's a safety thing, I know.
The bonnet isn't set to hold the full cylinder pressure.
Yes.
Why
No, I know, I know. That's the
So you don't want that bonnet to blow up. So
Yes.
you got a vent hole on there. And it's threaded. In this case, this is our 3200 regulator. It has a 16th inch pipe thread on there. So you just get a pipe adapter to whatever tubing you're running on that. So you use that for corrosive gas service or flammable gas service.
Yes, and when we send them out, when we send our regulators out, they will have a piece of tape over the Bonnet vent hole. And this is a dual stage, so there's 2 Bonnet vent holes for each of the stages.
Okay, this is next question is from we're going to use the same regulator. We have a customer who has it. We're going to build a panel for them for acetylene. It's a high flow system. And we have to use our 3200 series. This is a high flow line regulator. And it needs to be set at 15 psi for acetylene because you don't want to use acetylene over 15 psi. It could be dangerous. The customer is concerned about, well, gee, what if the regulator fails? And they were thinking, oh, well, you really need to have another regulator in there. So you'd have, the first regulator, and then, actually it's kind of backwards. The gas would come in here. So there'd be the first regulator and the second regulator. Now, there's a couple problems with that. First, one of the minor problems is flow rate. For acetylene, we figure about 200 psi on the inlet. You set this for 15 psi, and then this will handle the flow that they need. Now, if you put another regulator on there, well, guess what? You only have 15 psi going into this, and you want to get 15 psi. Well, you're not going to get 15 psi, but you have to get flow rate with 15 psi in, and this really isn't going to handle the flow rate that you need.
Yeah.
So that's one of the issues.
Yeah.
Is that
Obviously, one of the main things that affect the flow rate is the difference in pressures.
Yes. Yeah. The other issue is when we get questions like this, people are concerned about safety of their system, and they want to have they think having a backup is the way to go. But if the first regulator fails, you know what? The second regulator could fail too. So you need to have your system designed
and you wouldn't
to handle that.
And I guess if you looked at the gauges, you'd be able to find out. No, and you wouldn't even know if the regulator. No, yeah, you'd know.
You're not going to be there when it fails.
You're not going to be there when it fails. So you're not going to know.
Yeah. So in this situation, we suggest you have a properly sized relief valve or safety valve downstream to handle if you have a problem with that. Okay. Next question is this is the regulator for the next question. Person says, I have a 3513-330 regulator with a maximum outlet pressure of 50 psi. I need to order a regulator that has a maximum outlet pressure of 300 psi. It looks like I'll need to order a 3517A regulator. I want to know if this is in the same family and will be compatible to use with 100 ppm THT and methane mix.
So this is our 3517A regulator. Well, the 3510 series regulator. I don't know exactly what the output pressure is off the top of my head. And so the regulator that she mentioned did not have an A on it, so it's just a 3513 without the A. So that was our older family of regulators for this type.
Yeah, and that's like 10 years old.
10 years old. However, they are still very similar regulators. So using the 3517A in a, if you're familiar with the 3510 series without the A, they will be very similar regulators, and you'll be able to use them just fine in the same applications.
Yep, that's good. Okay. And we got our next question.
Yeah, fluorine.
Yeah, this is, I'm looking for a pressure regulator capable of being used in up to a 20% concentration of fluorine. Okay, fluorine is extremely reactive gas, and simple answer is we don't have anything that can handle a 20% fluorine mix. Try to explain why. Anything above 10% fluorine, the valve seat in the regulator needs to be bronze-filled Teflon, or PTFE. And I think you'd really need to have it Monel. And so we don't have that kind of regulator that they need. But if your concentration is below 10%, and we sell quite a few of these, this is a 3810 series, and we'll be able to use this for below 10% fluorine. Mixes. It's a stainless steel dual stage regulator. We can also do it for the 3610A regulator or the 3510A regulators, or stainless steel ones, and they'll be acceptable for 10% or below fluorine service. And if you needed a cross purge on there on the inlet, because with the high pressure and the fluorine concentrations, you have to limit your fluorine concentration to 5%. So that's it on there.
And just to be clear, we do not carry a regulator that can do above 10% fluorine. Is that correct?
Correct. That's correct. Well, that's all the questions we have for this week. Please tune in next week for another edition of the Bill and Corey Show.
Set your VCRs.